Hello, physics problem. Coefficient of friction and speed. A roller coaster reaches the top at speed of 6.0 km per hour and descends the hill with an angle of 45 degree and distance 45 meters. Estimate its speed, the final speed at the bottom when the coefficient of friction is 0.18. So first of all, we have to make a free body diagram. So this is like this one. This is inclined surface plane. So this angle is theta, and say this is at the top. So this is mg, and this is the normal force. And this is the force with which this is MA, which is going downward. And this is the friction force, which is FR. And on this side is the resolve vector, and this is the other component. This is angle theta. And this is equal to mg cosine of theta. And this is equal to mg sine of theta. So we will resolve this one. So along x-axis, so sum of the all forces along x-axis is equal to 0. So we will use this frame of reference. This is x-axis and this is y-axis. So along x-axis, this is FR is positive, FR. This is negative minus MA, and this one. So this force, and this force will be used. So this is also minus mg sine of theta, which is equal to 0. So from here we can find out this ma. So this will go on other side. So ma, which is equal to friction force minus mg of sine theta. This is equal equation 1. Similarly, on y-axis, sum of the all forces along y-axis should be equal to 0. So from here, Fn on these two, so these two forces, so Fn minus mg cosine of theta. So this is equal to 0. So Fn is equal to mg cos of theta. So this is equation 2. But friction force is equal to nu time Fn. So the Fn is this one. So this is equal to nu mg into cosine of theta. This is equation 3. So friction force Fr. So if you put this value here, then Ma is equal to Fr is equal to this one. So nu mg into cos of theta minus mg sine of theta. So this, so from here we can find out the m is cancelled throughout. So we can have a, which is equal to g cos of theta minus g is also common into and mu minus sine of theta. So this is equation 4. So this equation is fine. We have to find the value of speed. So we can use, there's no time involved. So that's Vf square, which is equal to Vi square plus 2As. So this is the final speed. This is initial, and this is acceleration, which is and this is distance. So vi, which is equal to, which is equal to 6 kilometers, 6 kilometer 1000 per hour, 60 minutes multiplied by 60 seconds. So this is a meter per second whole square plus 2 a. A is this one, 9.81 into this mu is 0.18 into cos of 45 degrees minus sine of 45 degrees. This is 2a and s. S is equal to 45 or multiplied by 45. So this is V final square. So if you calculate this one, then we will have a VF which is equal to 23 meter per second square, and then 23 meter, if you convert into kilometer per hour, so divided by 1000, so this is a kilometer, and multiplied by 60, so this is per hour. So this will give you the value of 86 kilometer per hour, which is the final velocity, final speed. So this is the answer of the question, which is slightly complicated. So the roller coaster reaches the top at the speed of 6 kilometer per hour and then descends. So it comes here and then descends. So the force is this one, the friction force is backward and normal force is upward. And then we can do some of the forces along x-axis, some of the forces on y-axis, and then we can use the Sweat equation, and then we can find out the final speed.